Hey guys, good morning. Welcome to the Aerospace Structure Lecture Series. This is Professor Nehru, Department of Aerospace Engineering, SNS College of Technology. So today we are going to see the law of Maxwell's reciprocal theorem. So in last three classes, we have seen about the strain energy methods, the problems on strain energy. Now we are going to see the law of reciprocal deflection, or we call it as Maxwell's reciprocal theorem. In any beam or a truss, the reflection at any point, let us take at the D point, due to a load W or P at any other point, C is the same as the deflection at the C due to the same load W applied at the point D. Let us take the span AB, where the in picture 1 the load is acting at the point C. Due to that load W at the point C, the deflection at the point D will be delta deflection. If you change the load in the deflection point, and the deflection you can calculate by the loaded point C and D, the same will be calculated. So this is the thing can be repeated or reciprocal from the load and the deflection. The figure 1 shows a structure AB carrying a load W applied at the point C. At the deflection C, the delta will be delta C. And the deflection at any other point, delta D. The figure 2 shows the same structure AB carrying the same load W at the D. That is, deflection at the C is delta C, and the deflection at the D is delta D. Where the structure loaded as shown in the figure 1, work done on the structure equal to half times of load into deflection. And the structure is loaded with a load W at the C. The another equation for the loaded W can be applied at the D. There will be a further deflection delta C and delta D at point C and D shown in the figure. The total work done at the stage is equal to half time W delta C plus half time delta D plus half time delta C at all the point. This is the work done on the structure is equal to half time to delta D. So deflection at the C is equal to the deflection at the D is equally reciprocal. The proof of this Maxwell reciprocal theorem, let us consider the cantilever beam of loaded with load W at the free end B. The span is AB. The span is AB. The load at the point W. The shear force and bending moment diagram is calculated at the A and B point. The deflection is higher in the point B. Shear force is A at the point A. The reflection of the point distance A from A is the B will be equal to the moment of M by EI from the pure bending equation. The diagram between A and C about the point C. The delta is C equal to W A square by 2 EI into L minus A3. Now consider the same cantilever loaded with beam loaded with a load W at the point C. This shear bending moment diagram and shear force diagram will be vary. Whereas delta B equal to W A square by 2 EI equal to L minus AE. So deflection of the C is equal to deflection of the B is verified. Now coming to the Castigliano's theorem. The Castigliano's theorem, we have two things. One is first theorem and second theorem. The first theorem of the Castigliano states that the partial differential of the total strain energy in any structure with respect to the applied force or moment gives the displacement or rotation respectively at the point of application of the force or moment in the direction of applied force or moment. So du by dp is equal to delta 1, that is the due change in partial change of strain energy due to the applied load is created the deflection, or the partial differential strain energy with respect to moment will create the rotation. Castigliano's second theorem, the second theorem of the Castigliano states the work done by the external force in the structure will be minimum. The theorem is very much useful in analyzing static equilibrium structures. W into work done by the external force on the structure. U equal to strain energy stored in the structure. W1 is equal to work done by the reactive forces. Strain energy U equal to W1 plus W2. Castigliano's second theorem should be minimum, so the partial differential of the work done with respect to the external force will be 0. In the case of suppose or underlying, the work done by the reactive forces will be 0. Strain energy stored is equal to the work done by the external force will be minimum. Thus, the partial differential of the strain energy with respect to the redundant reaction will be 0. Castigliano first theorem in the determining deflection of a structure, and the second is in the determine the redundant reaction component. So this is the Castigliano one, theorem 1 and theorem 2. We'll see the problems on Castigliano's theorem in the upcoming classes. Thank you.